So as we go through the exam paper, you're going to start to find that there are more and more questions that resemble ones earlier on, like 1/2 plus 1/2, or they might have 1/4 plus 3/4 or 3/4. And those are pretty straightforward, but then you get towards the end and you start to think, oh, hold on, they're getting a bit more complex. And this is absolutely fine because they're increasing the challenge as you go through the paper. Now, it might happen randomly on this year's paper, I'm not sure, but there's only so many questions that they will ask you because they're all linked back to the curriculum. They're not going to ask you something that you haven't been taught. So let's have a look here. I mean, that isn't featured on the curriculum. So if something hasn't been taught at school, it's always a good idea if it came up in your SATS practice question to ask a grown up, to maybe ask a teacher at school to see, has this been covered yet? Like, for example, if you're in year 5 and you haven't done a division of fractions and it comes up on a SATS practice paper, it might be something that your teacher will tell you that will happen in year 6. So you could get some extra help there before you come across that. So anyway, let's start. So 28%, if you look at this little symbol here, if we rearrange them, it just looks like 100. And this is so useful because this really is 28 over 100. Now, I just also wanted to talk about like when we multiply by 10 and we divide by 10. Now, when I was at school, when we multiplied by 10, my teacher would just say, add a 0 to the number. And if we divided by 10, she would say, knock off or take off the 0 at the end, but I didn't really understand why thoroughly enough. And that is because it should be based in place value. So this absolutely has its merits, and this is a wonderful shortcut, and I still use it today. But the reason why I use it is because I understand this part of it, and I want you to understand too, and I'm sure you do. So we have our tens column and our units column, and then we have our tenths column. Now I say units because if I put a 0, sometimes it looks like the zeros column. So let's call it units, but it really is ones. Okay, so if I have, for example, 125 and I want to divide it by 10, what's really happening here? There's 1 0 and each of these columns is a 0. I am just moving these numbers one space to the right. It's a bit like if you're in the cinema and you're sitting in the wrong seat and someone says, oh, do you mind moving up one, please? So now you have your 5 is here, and now your 2 is here, and now your 1 is here, and 125 divided by 5, sorry, divided by 10, not 5, divided by 10 is 12.5. Now, if we were to multiply it by 5, it means we move this way up the place value chart, and which means the hundreds would now go into the thousands column, the 2 would be moving into the hundreds column, and the 5 would move into the tens. There's nothing in the units. So it's just like my teacher had said, you pop a 0 on the end. Multiplying by 10 is lovely because you just put a 0 on the end. Unless we're looking at decimals. Now, if we're looking at 12.5, let's just erase this here. And I want to multiply 12.5 by 10. It's a little different because it's, again, like moving up your seat. The 1 will now move into the hundreds. The 2 is now moving into the tens. And the 5 is now moving into the units. But my teacher was right in a way because that space left here, you just put a 0. You can see that there. So we don't need to use that because that 125.0 goes on into infinity. Okay, so let's go back to where we started. And if you're watching this for the second time, skip past anything that you understand and just move straight into the question practice. So let's do it this way. So 28% is the same as saying 28 of 100. Remember, percentages, fractions, and decimals, they are all cousins, and their grandfather would be called grandfather divisions. They're all related to division because 1 over 2, if you look at the division sign, these dots represent numbers. That just means division, 1 divided by 2. Anyway, that's just an aside there. So of, when we're multiplying, when we are thinking about fractions of, is really multiplying. And then we have 650, and that's 651s. Now, the rule for multiplying fractions, so you will need to go over this on its own if you haven't done this before. But if you have done this before, remember, We can cancel down or simplify X ways, or we can go top to bottom, bottom to top. We can do it this way, that's fine. The way we can't cancel down, even if it's very tempting, is left to right. We can't do it like that. It doesn't work out. It will get the wrong answer. Okay, so let's do it. What times tables can we use here? I will use my friendly number 5, and I'm going to times it by 10 and think about 50. How many 50s in 100? Well, there's 2 5s in 10, so there's 2 50s in 100. And then how many 50s in 650? Well, there's 12 5s are 60, so that means that 13 5s would be 65, so that would be 13 50s. Okay, and then we look up and down here, and I can see that 28 and 2 can still be simplified. If I divide this by 2 and I divide that by 2, I've got a 14 and I've got a 1. Now we have a nice fraction to multiply. We have 14 times by 13 over 1. And we can do that together. We can stack it, we can partition it, but let's just do it like this for now. But we can do a different way. So when I'm multiplying and using long multiplication, I circle my first number. 4 3s are 12. 1 3 3 plus 1 is 4. And then I'm finished with that. So I move to my next column. 4 1s are 4. And 1 1 is 1. Let's add it together. And that's 182. But if that is a little tricky, there is another way to tackle this question. 10% of is also thinking about 10 over 100 times, and that just means divide by 10. So 650 divided by 10 equals 65. And then 20 would be double that, so that would be 130. Now, if 10% equals 65, then 1% would be 10 times smaller, which is 6.5, okay? So let's do that. So 6.5 and 6.5 is 13, and that's 2%. Okay, and then we want to times that by 4, because we want 8%. So 3 4s are 12. Put that there. 1 4 is 4 plus 1 is 5. So we've got 52. So we have 52. And then we also want our 20%. Okay, which is 130. And then we're going to add it together, and we get 182. And that's another way of doing that. Now, if you look at any of these methods and you're like, oh my goodness, I have no idea what's going on there, or you've lost me, that means there is a stage that we need to go right back to the beginning with, and then we need to practice that stage. So it could be finding 10% of things. It could be dividing numbers by 10. It could be looking at our times tables. Whenever you find something tricky, it's almost like you have a jigsaw puzzle and there's a couple of pieces missing. And once you slot those in place, you can see the whole picture. So if you get all the way to here and you think, oh goodness, I don't know, I can't find the answer to this, then try and work out what part is tricky. I always tell my students, you can say things like, I understood up to this part, but after that, it was very difficult for me. And that means that's where your knowledge has got to, and then we can extend it. So remember, there's always room to add to what we understand. Any questions, pop them in the comments below.